Hello. Today we're going to be multiplying special polynomials. And on this first slide I have a couple examples and I want to show you why these are considered special. So we're first multiplying x plus 6 times x minus 6. So let's go ahead and get started. We're going to do the FOIL process. So we're going to double distribute. So x times x, our result is x squared. We'll take the x times the negative 6. So minus 6x. Then we'll do the same thing for the positive 6. We're going to send that through. 6 times x, 6x. Plus sign there. And 6 times negative 6, remember it's multiplication, so you get minus 36. And when you combine like terms, notice that the middle terms are opposites, so negative 6 and positive 6. They cancel, leaving us with x squared minus 36. And that's our product. Let's look at number 2. We'll do the same thing. It's x plus 3, quantity x plus 3 times quantity x minus 3. So let's send the x through to both parts. X times x is x squared. X times negative 3 is a minus 3. And then we'll do the same thing for the 3. We'll send that through. 3 times x is plus 3x. 3 times negative 3 is minus 9. And when we combine like terms in the middle, you once again see that they are opposites. So x squared minus 9. So what's unique about these is that what's in the parentheses are almost the exact same. The only difference is that the signs are opposites. Therefore, the middle terms become opposites. The outers and inners part of FOIL. And they always cancel every time this happens, leaving you with just a binomial. Now let's look at these. These are also considered or going to be special products. And what's happening here is we're taking x plus 4 quantity squared. Now you need to think about what that means. X plus 4 quantity squared, to square something, you multiply it by itself. So we're going to take x plus 4 and multiply it by x plus 4. We can do the same process that we've been doing, the FOIL process. We're going to send the x through to both things, x squared plus 4x. Then we'll send the 4 to both, so positive 4x plus 16. Now these middle terms are the exact same. Notice they're both positive 4x's. So when we combine them, essentially it's just doubling one of the two middle terms. So 4x plus 4x, or doubling 4x to get 8x plus 16. Okay, and then the same thing for number 4. X minus 8 quantity squared means you take x minus 8 times itself, x minus 8. So let's distribute here, x to both parts, and negative 8 to both parts. And again, notice that your middle terms are the exact same. This is not a coincidence. It's going to happen every time. So you have x squared, negative 8x minus 8 more x gets me negative 16x's and plus 64. So these are considered special products because you're taking some binomial times itself. And like normal, you end up with a trinomial, but this trinomial is called a perfect square because you squared a binomial. Just like as if we were to take, say, the number 11 and square it, we get 121. 121 is called a perfect square. So too are these trinomials. And we are done.